Hello class, my name is Danny Deerdorf and this presentation is for Geog 481's final project proposal. The purpose of my project is ultimately to enhance public leaders' awareness of the health of the New River in Virginia. This will be accomplished by producing a risk assessment for county governors and/or the state governor on the impacts the Radford Army Ammunition Plant may have on the river. I will explore the possibilities of both natural and man-made disasters that the New River can encounter and how the geographic disposition of the ammunition plant is in a less than ideal location if water levels were to rise significantly. My geographic area of study will focus on the southwest region of the state of Virginia, located inside the outlined red box on the screen. This is where two large campuses, Radford University and Virginia Tech, reside, as well as a major logistic corridor, being I-81. So as you see on the picture on the left, in between the cities of Radford and Blacksburg, Virginia, is where the Radford Army Ammunition Plant resides. My area of study is a 4-mile by 3-mile or 31 square kilometers. I believe the size of this area is an adequate size for this project, and I won't run into any major data processing issues with my computer due to the file sizes I'll be needing for this area. You can see on the picture to the right that the ammunition plant sits low and directly in the middle of a large horseshoe bend of the New River, and a large portion of the plant is located just south of the river. Originally, in my project idea, I stated that I'd receive my data off the Virginia Geographic Information Network, or VGIN, which is a part of the Virginia Clearinghouse. However, I've decided that I'm more comfortable with using OpenTopography, as I've already extracted files and metadata from this source before. The data set that I'll be using is OpenTopography Virginia South Central Bravo 1 27 dataset, which was surveyed from November of 2017 to May of 2018. Some of the data specifications include a horizontal coordinate system WIGS 84, Web Mercator, a vertical coordinate system of NAV D88 height geoid 12 Bravo in meters. And it has a point density of 11.5 points per meter squared. This data set was tested to 0.1311 meters, vertical accuracy at the 95% confidence level, with the average error of 0.055 meters, an RMSE of 0.067 meters, and a standard deviation of 0.046 meters. The data was collected in a Cessna 172 aircraft, single-engine aircraft, with a Regal VQ 780i system. It was flown at an altitude of 1,600 meters above ground level or 5,200 feet above ground level. I plan to download my data in LAS format, then use software we've used in this course to decompress the data. A minor issue that I may run into is the fact that OpenTopography only allows downloads for 250 million points and less. And if you look at the picture on the left, it looks like my entire area of interest is more than that. So I will download my whole area with ground points only. And if you look at the right, I'll then select a smaller area inside the ammunition plant that also includes the New River with all points. And that'll be under the 250 million points. Software package or packages I'll be using for the project are LP360 and ArcGIS Pro. I found that in the Lesson 6 lab that we'll hydroflattened rivers, which is the picture shown here. And I believe it'll be useful in my project for the new river. For my workflow diagram, I'm currently at step 3 of my workflow. I wanted to add in steps of reading my peer reviews and taking that advice and adjusting it to my project as I see fit. So feel free to leave a review so I can use any advice necessary. After the reviews of this proposal, I'll download any necessary data on Open Topography and upload the data in LP360. Something we've all learned is absolutely necessary in our workflow is to make sure the spatial reference system is accurate for the project specified. So that'll be my next step. After this, I'll create Earth models and apply point cloud tasks that I see fit. I think I'll likely use only point cloud taskings that we've accomplished in lessons thus far. So that way I have a relative guide helping me along the way. I'll then apply hydroflattening to the new river using downstream constraints, as we'll learn in lesson 6. And just a fun fact, the New River is one of the only rivers in the US that flows to the north. After this, the next step is where I believe I'll incorporate ArcGIS, particularly with the raster calculator, to produce a DEM DSM and an NDSM. And then lastly, I'll capture some of the snapshots throughout my workflow of LiDAR data to include into my risk assessment that I produce for the public leaders. All right, class, any questions, comments, ideas are welcomed. This picture, courtesy of FlightAware, is of a Army aerial ISR platform called the EMARS or the MC-12, and it actually has LiDAR capability on board. This is an aircraft that I haven't flown personally, but I could potentially in my military career. Thank you for listening, and good luck.